These are the 10.2 notes, the law of cosines, pages 1 and 2. Now we're going to start this the same way we did with the law of sine notes, and that is seeing where this formula comes from really quickly before we go ahead and apply it. So notice here we've got our triangle ABC. We've got the opposite sides labeled little a, little b, little c. We've also got a couple of other pieces in there, and we're going to walk through those really quick. So here's what we're going to do. We are going to draw the altitude K from vertex C, and that's this right here, which is already in here for you. Notice this time when we split this into two right triangles, we are also looking at how that side C is divided. So if we're calling the whole side C, I can take one little piece and call that X, and then I'm going to take the other piece and call it C minus X. Feels a little funky doing that because we're adding in another variable when it already seems like we have so many. But just like before, we're going to kind of use that K and X to work through and come up with an equation that involves the sides and the angles of our triangle. Okay, so part A says draw altitude K, separate sides side C into segments C minus X and X, and we have those in there. B asks us to recognize that altitude separates our original triangle into two right triangles. So we're going to use the Pythagorean theorem here, which we can use anytime we have the sides of a right triangle. We want one that relates KB and C minus X. So let's see, that is this triangle over here. And so I want to make sure that I get the parts right. So C minus X is one of my legs, K is one of the legs, and B is the hypotenuse. Okay, now we're going to take a look at the other right triangle that was formed. That's this one over here. We've got legs X and K, and hypotenuse A. And so we're going to write that as X squared plus K squared equals A squared. So a little unsettling. I've got variables A, B, C, X, and K. Feels like a whole lot, but notice that both of these involve K, so we're going to solve each equation for K. So over here I have K squared equals B squared minus C minus X squared, and we're going to go ahead and multiply that out in a minute. Right now I'm going to leave it like this. Over here I have K squared equals A squared minus X squared. Okay. Both of these are equal to K, so we're going to do the same thing we did with law of sines and set them equal to each other. I get B squared minus C minus X quantity squared equals A squared minus X squared. Okay, now we've got to figure out what to do with the X. If we go back to our original triangle, notice our sides are A, B, and C. X is not really part of what we know about the triangle. So we're going to see if we can rewrite this without using the X at all. So we are going to start by expanding that C minus X squared. I get B squared. I'm going to leave this in parentheses for a minute. C squared minus 2CX plus X squared. And then I'm going to go ahead and distribute that negative through. I'm going to solve that equation for B squared by moving everything on that side to the other side. So here I'm going to add C squared to both sides. I'm going to subtract 2CX and I'm going to add x squared. And what I get now is b squared equals a squared plus c squared minus 2cx. Notice that I've got that minus x squared plus x squared. Those are going to cancel each other out. Okay. I still have an x involved, which I'm not crazy about. So let's go back up here. I'm going to take a look at the purple triangle, my smaller right triangle, and I want to come up with a way to get rid of that x. So our hint tells us to write an equation involving cosine b and x. So if I come back up here and take a look at my triangle, cosine b equals, my adjacent side is x over hypotenuse is a. So a times the cosine of b equals x. Okay, so from the triangle, a cosine b equals x. So I'm going to go ahead and substitute that in right above here. So I've got b squared equals a squared plus c squared minus 2 times c, and that x is a cosine b. And since we like things a little more organized sometimes, I'm going to rewrite this just one more time. B squared equals a squared plus c squared minus 2. Anytime I have multiple variables, I like them in alphabetical order. So I'm going to put a before c times the cosine of b. This is the law of sines. You know it. Notice it involves 3 sides and 1 angle. And again, we've written this in terms of b squared. We can rewrite this, looking at the patterns here, with the other 2 sides. So H identifies that equation as the law of cosines. So this is right here. Okay. We are going to rewrite this. This is one of those situations. It's nice to be able to see the patterns and just know what pieces you're substituting in. So I'm going to rewrite this with a squared. It's the sum of the other 2 lengths squared, so b squared plus c squared minus 2 times those other 2 sides times the cosine of the angle opposite the side we're talking about. Excuse me. So last one, c squared is going to equal a squared plus b squared minus 2 times a times b times the cosine of angle c. Notice that the pattern holds, looks exactly the same in all 3 of them. Whatever side length is alone on the side of the equation, that's the angle on the other side. Okay. Sometimes you're asked to solve for the angle. Pretty easy to just plug values in and numerically work through. I will tell you, though, that students tend to make mistakes with the a squared plus b squared minus 2ab part. They see numbers there. They want to combine all those and multiply by c rather than realizing that that 2 times a times b is multiplied by the cosine of c. So down here, what I have listed for you is how we're looking at these if we are solving for an angle. So you can get these by plugging the values into the equations above, or you can just start off with these ones. So on the next page, we're going to talk about solving a side angle side triangle using the law of cosines. These are the steps that you've got listed in the text. Okay. It helps to sketch the triangle with these equations. Sometimes students don't feel the need to do that. That's fine. You're going to use the law of cosines to find the length of an unknown side or angle, whatever you can find first. And then you're going to use the law of sines or cosines. Fix that typo there. Law of sines or cosines to find another angle, and then we're going to use the fact that the three angles in a triangle add to 180 to find the third angle.